What is a vector?
A vector is considered to be an element of a linear or vector space. A vector is different than a point, as it represents the displacement between 2 points, not the physical location of a point in space. Vectors also define a direction, points do not. Vectors are usually represented by a line segment in a specific direction on a graph, with an arrow at one end of the segment.
What are some examples of matrices?
The dimensions of a matrix are the number of rows, horizontal numbers, and columns, vertical numbers. It is written as the rows first, columns second.
What is a logistic equation?
A logistic equation, resulting in a curve on a graph, represents the exponential increase in numbers of a species until it reaches the carrying capacity in its specific environment. This carrying capacity, usually referred to by the letter K, is the maximum population size that can be regularly sustained by an environment. Change the environment and K changes, for example, by such events as adding a predator, removing a competitor, or adding a parasite.
What movies had mathematics as their primary focus?
The following 3 movies were either about mathematicians or had a dominant mathematical theme. A Beautiful Mind, 2001, based on the book by Sylvia Nassar, also see above. This is Hollywood's version of John Nash's rise, descent into mental illness, and eventual redemption. Directed by Ron Howard, it stars Russell Crowe and Ed Harris. Pi, 1998, this dark, low-budget, black and white film is about a mathematician's obsessive search for patterns in everything. While everyone from Wall Street investors to religious fundamentalists want to find and exploit him. Directed by Darren Aronofsky, it stars Sean Gullett and Mark Margolis. Infinity, 1996, this movie about the early life of brilliant and eccentric Nobel Prize-winning physicist Richard Feynman. 1918 to 1988, is both a tribute to the scientist and a whimsical romance. Directed by Matthew Broderick, it stars Matthew Broderick and Patricia Arquette.
What are some familiar Arabic terms used in mathematics?
There are numerous Arabic terms we use today in our studies of mathematics. One of the most familiar is the term algebra, which came from the title of the book. Al-Jabr w al-Muqabala by Persian mathematician Muhammad ibn Musa al-Khwarizmi, 783 c. 850, also seen as Al-Khwarizmi and Al-Khwarizmi. He was the scholar who described the rules needed to do mathematical calculations in the Hindu Arabic numeration system. The book, whose title is roughly translated as Transposition and Reduction, explains all about the basics of algebra. For more information, see algebra. Another Arabic derivation is algorithm, which stems from the Latinized version of Muhammad ibn Musa al-Khwarizmi's own name. Over time, his name evolved from al-Khwarizmi to al-Khwarizmi, then algoritmi, algorithmus, algorithm, and finally algorithm.
Why were early Greek calendars such a mess?
And like the Mesopotamian cultures, the early Greeks paid less attention to astronomy and more to cosmology. They were interested in studying where the Earth and other cosmic bodies stand in relation to the universe. Because of this, their astronomical observations were not accurate, creating confusing calendars. This also led to a major conundrum: almost every Greek city kept time differently. In fact, during the Greek and Hellenistic times, most dates were given in terms of the Olympiads. This only created another timekeeping problem: if something happened during the 10th Olympiad, it meant the event occurred within a 4-year span. Such notation creates headaches for historians, who end up making educated guesses as to the actual dates of Greek events. Important people's deaths and births, and other significant historical occurrences.
How are degrees and radians translated?
When measuring the number of degrees in a circle, another unit called radians is often used in trigonometry. It is known that a circle is 360 degrees, with 1 degree equal to 60 minutes, 60. And 1 minute equal to 60 seconds, 60. This is also called DMS, degree minute second, notation.
What are the common types of mathematical operations?
Operations are ways to obtain a single entity from one or more entities by manipulating numbers and letters, in certain ways. They include the elementary operations most of us are familiar with: addition, subtraction, multiplication, division, cubing, squaring, and integer root extraction. There are numerous types of other operations, too, including binary operations, in which two quantities or expressions x and y interact in set theory. For more about set theory, see Foundations of Mathematics.
What is a factor and what does factorization mean?
A factor is a portion of a quantity that when multiplied by other factors gives the entire quantity, or product. In order to determine such factors, or divisors, you have to use factorization, also called factoring or to factor. When factoring an integer, it is referred to as prime factorization. When factoring a polynomial, it is called polynomial factorization.
What are the main parts and types of computers in use today?
The basic parts of a computer are the central processing unit, CPU, memory, a keyboard and other optional input devices such as a scanner, and output devices such as a screen, a printer, and audio speakers. The biggest differences between the various types of computers are the amount of memory and speed of the machines. It's also easy to see why the word computer has so many connotations. They vary greatly, but include the following basic types, which are based mostly on the size and number of people who can simultaneously use the machines. The mainframe is considered the largest and most powerful general-purpose computer system. It is usually used to fill the needs of a large agency, company, or organization, because it uses hundreds of computer terminals at the same time. Supercomputers are sophisticated machines designed to perform complex calculations at maximum speed. Because of their speed and the great amount of data they can work through, they are most often used to model huge dynamic systems with many variables, such as weather patterns and groundwater flow. Microcomputers are usually subdivided into personal computers, or desktop computers, and workstations. Oftentimes, microcomputers are linked together in a local area network, LAN, or by joining the microprocessors in a parallel processing system. This allows smaller computers to work in tandem, often giving them comparable power and computational abilities to mainframes. Familiar to many people today are notebooks and laptops, which are very similar. Laptops are small enough to fit on a person's lap. Notebooks are usually a bit smaller and lighter than a laptop. The newest ones often have the same capabilities as a desktop computer.
What are some special properties of zero?
There are many special properties of zero. For instance, you cannot divide by zero, or have zero as the denominator bottom number of a fraction. This is because, simply put, something cannot be divided by nothing. Thus, if some equation has a unit, usually a number, divided by zero, the answer is considered to be undefined. But it is possible to have zero in the numerator, top number, of a fraction. As long as it does not have zero in the denominator, called a legal fraction, it will always be equal to zero. Other special properties of zero include, zero is considered an even number. Any number ending in zero is considered an even number, When 0 is added to a number, the sum is the original number. And when 0 is subtracted from a number, the difference is the original number. Square of the length of the radius, or as it is often phrased, pi r squared.
What is the Monty Hall problem?
Let's Make a Deal, a once popular television game show with host Monty Hall, who was the master of ceremonies from 1963 to 1986, is the origin of the Monty Hall problem. The same type of problem is also represented in a card game called 3-Card Monty. The Monty Hall problem is similar to the show. A contestant is given a choice of 3 doors. Behind one is a car, behind the other 2 there is nothing. The host asks the contestant to pick a door. After the pick, the host opens one of the unpicked doors. One the host knows is empty. The host then suggests a switch. The big question, and the problem, becomes, does the contestant switch his or her choice or keep the originally chosen door? The mathematical, statistical answer is yes, switch the doors. Why? Because the original probability that the contestant picked the correct door does not change. It is still 1/3. But if the contestant does switch, the probability becomes 2/3. Most people believe that once one of the doors is eliminated, the probability between the remaining doors becomes 50-50, but it does not.
Are there higher derivatives of a function?
Yes, there are higher derivatives of a function, often referred to as higher order derivatives. The initial derivative is often written as f, x, but the is assumed in most cases. The next derivative is the second derivative, second order derivative, most often written as f, x. The next is the third derivative, or third order derivative, most often written as f, x. Fourth derivative, or fourth order derivative, most often written as f, 4, x, and so on.
What is quantum mechanics?
Quantum mechanics is a branch of quantum theory that simply determines the probability of an event happening. Although the mathematical calculations to prove such things are very rigorous and complex. In fact, quantum mechanics is often called the final mathematical formulation of the quantum theory. Developed during the 1920s, it accounts for matter at the atomic level and is considered an extension of statistical mechanics, but is based on quantum theory. One important part of quantum mechanics is wave mechanics, which is an extension of quantum mechanics based on Schrödinger's equation. This idea states that atomic events can be explained as interactions between particle waves. For more on Erwin Schrödinger, see History of Mathematics.
Where did the symbols for division originate?
The history behind the division symbols is long and complicated. The following lists how the major ones developed, closed parenthesis the arrangement 8, 24, meaning 24 divided by 8 in this case. Was used by Michael Stifel, 1486 or 1487 to 1567, in Arithmetica Integra, 1544. The obelisk by 1659 Swiss mathematician Johann Heinrich Rahn. 1622 to 1676, introduced the division symbol, O, called an obelisk, in his book Touche Algebra. The symbol was a combination of colon and dash. This division symbol was used by many writers before Rahn as a minus sign. In 1668, when Rahn's book was translated into English with additions by English mathematician John Pell. 1610 to 1685, the division symbol was retained. Some say Pell greatly influenced Rahn to develop the symbol. But most historians agree that there is little evidence of such a connection. Another sign for division, the slash, was actually first used for fractions, such as 2/3 or 1/2. It can be extended into other, larger, or smaller numbers, such as 123/112 and 0.112/0.334. Little is known about its origins, but it is known that the symbol was sometimes used for subtraction, until it became standard practice for representing division.
What is a solar-based calendar?
A solar-based calendar is one based on the apparent movement of the Sun across the sky as we orbit around our star.
What is an exponent in terms of algebra?
An exponent is actually raising a number to a certain power. This is written as a superscript to the right of a real number, such as 34, expressed as 3 raised to the 4th power, or 3 with an exponent of 4. For more information on exponents, see Math Basics. The exponent represents the number of times a number is being multiplied. The above example, for instance, actually means 3x3x3x3, which is equal to 81. The power can be an integer, negative or positive numbers, real number, or even a complex number. This can also be thought of as taking the quantity b, the base number, to the power of another quantity often called e, the exponent. In many computer-oriented texts, this is written as b⁻e. Exponents are important to algebra as they are often included in algebraic equations. The process of performing the operation of raising to a power is known as exponentiation. Exponents are also often associated with functions. For example, in the function f, x equals x2, the 2 is the exponent.
What is environmental modeling?
As with most of the sciences, mathematical modeling and computer simulations also come in handy for environmental applications on a local, regional, and global scale. For example, scientists model environmental landscape changes, global climate change and the impacts on ecosystems, watershed and reservoir interactions, and forest management and sustainability.
What are the oldest surviving counting boards?
To date, the oldest surviving counting board is the Salamis tablet. Discovered in 1846 on the island of Salamis, it was once thought to be a gaming board. But historians have since determined that the white marble slab was actually used to count items. The tablet, which measures 59 inches, 149 centimeters, in length, 30 inches, 75 centimeters, in width, and is 1.8 inches, 4.5 centimeters, thick, was used by the Babylonians around 300 BCE. It contains 5 groups of markings, with a set of 5 parallel lines equally divided by a vertical line in the center. Below that is a group of 11 parallel lines, all divided by a perpendicular line. But this was not the only counting board of that time. After the Salamis tablet was developed, the Romans brought out the calculi and the hand abacus around 300 BCE to 500 CE. These counting boards were made of stone and metal. One example of a Roman abacus had 8 long and 8 short grooves arranged in a row. Beads would slide into the grooves, indicating the counted units. The longer grooves were marked I to indicate single units, X to indicate tens, and so on up to millions. The shorter grooves were used to indicate multiples of 5, 5 units, 5 tens, and so on. There were also shorter grooves on the right side of the abacus, which were probably used to indicate Roman ounces and for certain weight measurements.
How do you reduce a fraction?
To reduce a fraction, there are 3 general steps: factor the numerator, factor the denominator, and cancel out the fractional mixes that have the value of 1. The leftover number is the reduced fraction. For example, to reduce 16/56, the reduced fraction equals 2/7.
What are some types of math used in the legal profession?
Lawyers from civil to criminal need to know mathematics for a number of reasons. For example, when an attorney writes a brief for a case, he or she structures his or her argument like a geometric proof, which is similar to proving theorems by presenting all the relevant facts and laws. Statistics and accounting are valuable, 2. Because many times large amounts of money are involved in estate suits or other such cases. Knowledge of percentages, interest, and so on are needed. As well, to determine fair settlements for all the parties involved. Lawyers even have to delve into the field of logic. Especially symbolic logic that helps them interpret bad arguments and fallacies in the courtroom.
What are some characteristics of numerical analysis methods?
Characteristics of numerical analysis methods include accuracy. The numerical approximation should be as accurate as possible. Robustness. The algorithm should be able to solve many problems and should relate to the user when the results are inaccurate, and speed. The faster the computation, the better the method.
What does this mean for our calendar?
It is already known that our calendar and the length of a year were only off by 24 seconds. 0.00028 days, in 1582, a very small discrepancy that will eventually be noticed. But when you add in the slowing down of the Earth's rotation, it will make the year even shorter. In fact, since 1582, the year has decreased from 365.24222 days to 365.24219 days. Or an actual decline of about 2.5 seconds.
How did mathematical analysis develop after the 16th century?
Ideas about mathematical analysis took a long hiatus after the Greeks. It didn't begin to grow again until the 16th century, when the need to examine mechanics problems became important. For example, German astronomer and mathematician Johannes Kepler, 1571 to 1630, needed to calculate the area of sectors in an ellipse in order to understand planetary motion. Interestingly, Kepler thought of areas as the sums of lines, a kind of crude form of integration. Even though he made two errors in his work, they cancelled each other out and he was still able to determine the correct numbers. By the 17th century, many mathematicians had begun to contribute to the field of mathematical analysis. For example, French mathematician Pierre de Fermat, 1601 to 1665, made contributions that eventually led to differential calculus. Bonaventura Cavalieri presented his method of indivisibles, one he developed after examining Kepler's integration work. English mathematician Isaac Barrow, 1630 to 1677, worked on tangents that formed the foundation for Newton's work on calculus. Italian mathematician Evangelista Torricelli, 1608 to 1647, added to differential calculus and many other facets of mathematical analysis. In fact, collections of paradoxes that arose through the Inappropriate use of the new calculus were found in his manuscripts. Unfortunately for mathematics, Torricelli died young of typhoid. And, of course, the one name most associated with calculus, Isaac Newton, developed some of his most brilliant work during the 17th century.
Did the Egyptians use fractions?
Yes, the Egyptian numbering system dealt with fractions, albeit with symbols that do not resemble modern notation. Fractions were written by placing the hieroglyph for mouth over the hieroglyph for the numerical expression. For example, 1/5 and 1/10 would be seen as the first two illustrations represented in the box on p. 15 other fractions, such as the two symbols for 1/2, see illustration on p15, also have special signs.
What is bioinformatics?
Bioinformatics is a field that evolved by joining biology and information science. In the past few decades, advances in molecular biology and the increase in computer power have allowed biologists to accomplish tasks such as mapping large portions of genomes of several species. For example, a baker's yeast called Saccharomyces cerevisiae has been sequenced in full. Humans have not been exempt, either. The Human Genome Project was completed in 2003. It determined the complete sequence of the 3 billion DNA subunits, bases, for humans, identified all human genes, and made all the associated information accessible for further biological study. Since that time, other universities and agencies have taken on the task of analyzing the results, such as determining the gene number, exact locations, and functions. Such a deluge of information has also made it necessary to store, organize, and index all the sequence data, which is where information science, or the method to store and work on such large amounts of data, comes in the form of bioinformatics. The computer experts who deal with such information are known as bioinformatics specialists.
What are economics and econometrics?
Economics is a branch of the social sciences that deals with the production, distribution, and consumption of goods and services, including their management. The application of mathematical and statistical techniques to economics and financial data is called econometrics. It includes the study of problems, the analysis of data, and development and testing of theories and models.
What is a population pyramid?
A population pyramid is actually two back-to-back bar graphs that show the Distribution of a population by gender, one shows the number of males and the other shows the number of females. Most often in 5-year age groupings. These pyramids take a variety of shapes. For example, a triangular population distribution, also called a pyramid or exponential distribution, is usually indicative of a high birth and death rate, and a short life expectancy that is typical of less economically developed countries. A rectangular population distribution pyramid shows little change in size between the age groups. With more people reaching old age, this is typical of a more economically developed country. There are several uses for population pyramids. Besides calculating life expectancies, they are often used to find the number of dependents being supported in a specific population. Dependents in this case are considered to be children under 15, those attending school full-time and unable to work, and those over 65 years old or retired. Although this is a general definition and not applicable in all cases in all countries. Thus, governments can use such graphs to determine how much of the working population can support dependents. The graphs are also used to help predict future changes in terms of decades of a population's age structure. Historians use them, too, to find significant information based on past population pyramids.
How is barometric, or air, pressure measured?
Barometric, or air, pressure, named after the instrument used to measure this pressure, is caused by the weight of the atmosphere pressing down on the land, ocean, and air below, with gravity creating the downward force. Because pressure is dependent on the amount of air above a certain point, pressures are greatest at the surface and less at higher altitudes. On the average, at sea level, the air has a pressure of 14.7 pounds per square inch. A 1-inch square has 14.7 pounds of air pressure on each side. The United States National Weather Service does not measure pressure in pounds per square inch, but in terms of inches of mercury or how high the pressure pushes mercury in a sealed tube. Air pressure aloft is reported in millibars, or hectopascals HPA. A term most often used by scientists to measure air pressure. Most of us are very familiar with air pressure as it changes with the weather. For example, the use of the terms high pressure system and low pressure systems are often indicators of the types of weather fronts traveling through a region. In general, falling air pressure, seen on a barometer, means that clouds and precipitation are more likely. Rising air pressure means that clear weather is more likely. In addition, many people experience personal changes in air pressure. For example, the discomfort or even pain felt in a person's ears as they ascend or descend in an airplane. A large hill, or even in an elevator, is evidence of changing air pressure.
When was non-Euclidean geometry first announced?
Non-Euclidean geometry, or a system of geometry different from that developed by Euclid, cp. 17, was first announced by Russian mathematician Nikolai Ivanovich Lobachevsky, 1792–1856, also seen as Lobachevsky. In 1826. This idea had already been independently developed by the Hungarian János or Johann Bolyai, 1802–1860, in 1823, and by Carl Friedrich Gauss, 1777–1855, in 1816, but Lobachevsky was the first to publish on the subject. In 1854, German mathematician Georg Friedrich Bernhard Riemann, 1826–1866, presented several new general geometric principles. His suggestion of another form of non-Euclidean geometry further established this new way of looking at geometry. Riemann was also responsible for presenting the Riemann hypothesis, or zeta function, a complex function that remains an unsolved issue in mathematics today. For more information about geometry and Riemann, see geometry and trigonometry.
Is math ever used to solve crimes?
Yes, certain types of mathematics are often used to solve crimes. For example, police officers and crime scene experts use geometry to determine the conditions behind the crime. Angles come in handy to determine from what direction a drop of blood originated. Determine where a car was coming from when it struck another car, or to otherwise reconstruct a crime scene. Length measurements can be used to determine the stride and shoe size of a robber from the person's footprints. Some higher math comes in handy to see how fast a car was traveling as it slammed on its brakes, a task solved by measuring skid marks. At murder scenes, forensic personnel can measure the splatter pattern of bloodstains on a wall to determine where the murdered person was standing, or even measure the size and angle of a bullet wound to determine the distance from, and position of, the murdered person to the murderer. Probably the biggest connection between mathematics and solving crimes is how mathematics teaches people to improve their thinking habits. Math is a good way to develop problem-solving skills. And in everyday police work there is always another problem to solve.
Who was Alan Turing?
British mathematician Alan Matheson Turing, 1912–1954. Was the first person to propose the idea of a simple computer. Called the Turing machine, its operation was limited to reading and writing symbols on tape. Moving the tape to the left or right to read the symbols one at a time. This invention is often considered the start of the computer age. In fact, The definition of the word computable is a problem that can be solved by a Turing machine. Turing was also instrumental in interpreting and deciphering encrypted German messages using the Enigma cipher machine. For more information on computers, see Math in Computing.
How are modern abaci used?
Today's standard abacus is typically constructed of wood or plastic and varies in size. Most are about the size of a small laptop computer. The frame of the device has a series of vertical rods or wires on which a number of wooden beads slide freely. A horizontal beam separates the frame into two sections called the lower and upper decks. For example, in a Chinese abacus, the lower and upper decks each have 13 columns. The lower deck has 5 beads per column, while the upper deck has 2 beads. Each bead on the upper deck has a value of 5, while each bead on the lower deck has a value of 1, thus, it is called a 1/5 abacus. To use the abacus, users place the abacus flat on a table or their laps. They then push all the beads on the upper and lower decks away from the horizontal beam. From there, the beads are manipulated, usually with the index finger or thumb of one hand, to calculate a problem. For example, if you wanted to express the number 7, you would move 2 beads in the lower deck and 1 bead in the upper deck. 1 plus 1 plus 5 equals 7. This modern abacus is still used by shopkeepers in Asia and many so-called Chinatowns in North America. Students continue to be taught how to use the abacus in Asian schools, especially to teach children simple mathematics and multiplication. In fact, it is an excellent way to remember multiplication tables and is useful for teaching other base numbering systems, because it can adapt itself to any base. For more about base numbers, see History of Mathematics and Math Basics.
What is a limit in calculus?
A limit is a fundamental concept in calculus. Unlike a limit mentioned above, as in a series or sequence, a limit of a function in calculus takes on a somewhat different meaning. In particular, a limit of a function can be described as the following: if f, x, is a function defined around a point C, but may not be at C itself, the formal limit equation becomes lim f, x, equals L. Thus, the number L is called the limit of f, x, when x goes to C.
How does one convert latitude and longitude to degrees from readings containing degrees, minutes, and seconds?
It takes simple mathematics to convert the degrees, minutes, and seconds of latitudes and longitudes into degrees only. It helps to know that there are 60 seconds in 1 minute, and 60 minutes in 1 degree. Therefore, to translate 65 degrees 45 minutes 36, also written as 65 hours 45 minutes and 36 seconds, south latitude into degrees, you would do the following calculation: minus 65 degrees, south makes the number negative. Plus 45 minutes x, 1 degree slash 60, plus 36 seconds x, 1 slash 60, x, 1 degree slash 60, equals minus 65.76 degrees latitude.
What are some examples of how early peoples counted?
There were several different ways that early civilizations recorded the numbers of things. Some of the earliest archaeological evidence of counting dates from about 35,000 to 20,000 BCE, in which several bones bear regularly spaced notches. Most of these marked bones have been found in Western Europe, including in the Czech Republic and France. The purpose of the notches is unclear, but most scientists believe they do represent some method of counting. The marks may represent an early hunter's number of kills, a way of keeping track of inventory, such as sheep or weapons, or a way to track the movement of the sun, moon, or stars across the sky as a kind of crude calendar. Not as far back in time, shepherds in certain parts of West Africa counted the animals in their flocks by using shells and various colored straps. As each sheep passed, the shepherd threaded a corresponding shell onto a white strap, until 9 shells were reached. As the 10th sheep went by, he would remove the white shells and put one on a blue strap, representing 10. When 10 shells, representing 100 sheep, were on the blue strap, a shell would then be placed on a red strap, a color that represented what we would call the next decimal up. This would continue until the entire flock was counted. This is also a good example of the use of base 10. For more information about bases, see Math Basics. Certain cultures also used gestures, such as pointing out parts of the body, to represent numbers. For example, in the former British New Guinea, the Bujali culture used the following gestures to represent numbers. 1. Left hand little finger, 2. Next finger, 3. Middle finger. 4. Index finger, 5. Thumb, 6. Wrist, 7. Elbow, 8. Shoulder, 9. Left breast. 10. Right breast. Another method of counting was accomplished with string or rope. For example, in the early 16th century, the Incas used a complex form of string. Knots for accounting and sundry other reasons, such as calendars or messages. These recording strings were called quipus, with units represented by knots on the strings. Special officers of the king called quipukamiaks, or keepers of the knots, were responsible for making and reading the quipus.
What are the properties of logarithms?
Logarithms have certain properties, depending on the interpretations of an equation. The following lists some of the most common properties. These rules are the same for all positive bases. Log 1 equals 0, because a equals 1. For example, in the equation 140 equals 1, the base is 14 and the exponent is 0. Because a logarithm is an exponent. This would mean the equation can be written as a logarithmic equation, or log 14 1 equals 0, 0 is the exponent.
What is a universal set?
A universal set actually applies to sets that are not universal but are chosen from a specific type of entity, such as sets of numbers or letters. Thus, the set of all the elements in a set theory problem are collectively called the universal set. In reality, however, the set of all things does not exist because there is no largest or all-inclusive set. And so the true universal set is not recognized in standard set theory.
What is the Monte Carlo method?
The Monte Carlo method gives approximate numerical solutions to a number of problems that are too difficult to solve analytically by performing specific statistical sampling experiments. Although forms of the method have been known for a while, it was initially developed for numerical integrations in statistical physics problems during the early days of electronic computing. It was named after the city in the Monaco Principality, some say, because of the simple random number generator of roulette played in the Monaco casinos. Others say the method's creator was honoring a relative who had a propensity toward gambling. But there is more to the Monte Carlo method than meets the computation. For one thing, there is more than one Monte Carlo method. For example, one method, called the Markov chain Monte Carlo method, has played a critical role in such diverse fields as physics, statistics, computer science, and structural biology. And the list of applications continues, as recently as the late 1990s. Researchers and statisticians began to realize the usefulness and power of Monte Carlo methods for prediction.
What is the universal gas law?
The universal gas law, also called the universal gas constant or the perfect gas law, is a chemical law that can also be looked at mathematically. It is represented by the equation PV equals nRT, in which P is pressure, V is volume, N is the number of moles of gas, R is the gas constant, and T is the temperature in Kelvin. For more about the Kelvin temperature scale, see Mathematics Throughout History.
What is projective geometry?
Projective geometry is a branch of geometry that deals with the properties of geometric objects under projection. It was formerly called higher or descriptive geometry. Projection includes the transformation of points and lines in one plane onto another plane. This is done by connecting the corresponding points on the planes using parallel lines similar to shining a light on a person's profile and producing a silhouette on a nearby wall. Each point on the wall is a projection of the person's head.
What is the degree of a polynomial equation?
The highest order power, or exponent, used in a univariate polynomial is called its polynomial degree or order. It is also defined as the largest, or maximum, sum of exponents that appear on the variables in the equation's terms. Commonly, the word degree is used more frequently because order has another meaning when discussing polynomials. You can also talk about degrees in reference to monomials, binomials, and trinomials. The degree of a monomial is the sum of the degrees of the variable in the equation. The degrees of the other polynomial equations are the greatest of the degrees in terms after the equation has been simplified. For example, a third-degree trinomial equation is x3 3x2 equals 0.
What are the 5 postulates of Euclid?
Euclid was also famous for his postulates, propositions, statements that are true without proof and deal with specific subject matter, such as the properties of geometric objects. For more information about postulates, see Foundations of Mathematics. Along with definitions, Euclid began his text elements with 5 postulates. These postulates are as follows, some of which may seem obvious to us now. But in Euclid's time they had yet to be formally recorded. It is possible to draw a straight line from any point to another point. It is possible to produce a finite straight line continuously in a straight line. It is possible to describe a circle with any center and radius. All right angles are equal to one another. Given any straight line and a point not on it, there exists one and only one straight line which passes through that point and never intersects the first line, no matter how far the lines are extended. Another way to say this is, one and only one line can be drawn through a point parallel to a given line. This is also called the parallel postulate. Mathematicians first believed this last postulate could be derived from the first 4. But they now consider it to be independent of the others. In fact, this postulate leads to Euclidean geometry, and eventually to many non-Euclidean geometries that are made possible by changing the assumption of this 5th postulate. Like many early attempts at explaining mathematics, not all these postulates tell the entire geometric story. there were still a large number of gaps, many of which were gradually filled in over time.
What are non-vanishing and vanishing numbers?
A non-vanishing number means just what the term implies, a quantity that is non-zero everywhere. For example, in the expression x4 plus 1, the answer will never be 0. Even when x is 0 or a negative number. The answer for the expression x2 is called vanishing because if x equals 0, the expression's answer vanishes to 0.
What is a life table?
A life table is a statistical chart of mortality and survivorship of a group of people. Also called a cohort, of the same age at each stage of life. The results are usually shown as the probability of death and survival, as well as the life expectancy at various ages. There are two basic life tables, or expectations of life charts. A current, period or cross-sectional, life table is based on age-specific mortality rates for a given period. Either a single or many years. It assumes that as a group ages it has a set pattern of age-specific mortality rates that never change from year to year. But this is based on a hypothetical model of mortality, not the true mortality of the cohort. In a cohort, longitudinal or generation, life table, the people in the group are well defined. Usually of the same age, such as all the people are born in 2000, and have common experiences or exposures. Thus, it is based on age-specific mortality rates that allow for known or projected changes in mortality in later years. If the group is followed up for the incidence of diseases, for example, such as osteoporosis or heart disease development, it is called a cohort or prospective study. To compare, a current life table of life expectancy at age 65 in 2000 would be worked out using the mortality rate for age 65 in 2000, for age 66 in 2000, for age 67 in 2000, and so on. A cohort life table of life expectancy at age 65 in 2000 would be worked out using the mortality rate for age 65 in 2000, for age 66 in 2001, for age 67 in 2002, and so on. But note that not all cohorts are used in mortality studies. Some are also used for other reasons, such as a professor following a cohort of students who study together for the length of a certain degree program.
What is a linear combination?
Linear combination is a combination or the sum of two or more entities, with each multiplied by some number, with not all the numbers being zero. Linear combinations of vectors, equations, and functions are common. For example, if x and y are vectors and a and b are numbers, then x and by is a linear combination. For more information about equations and functions, see Math Basics and Algebra.
Is it possible to convert international units seen on such items as vitamin bottles to milligrams or micrograms?
No, there is no direct way to convert international units, IU, to mass units, such as milligrams. Most familiar to people who read vitamin and mineral bottles, an IU has nothing to do with weight. It is merely the measure of a drug or vitamin's potency or effect. Although it is possible to convert some items' IUs to a weight measurement, there is no consistent number. This is because not all materials weigh the same and the preparation of substances vary, making the total weights of one preparation differ from another. But there are some substances that can be converted, because for each substance there is an international agreement specifying the biological effect expected with a dose of 1 IU. For example, for vitamins, 1 IU of vitamin E equals 0.667 milligrams. mg, 1 IU of vitamin C is equal to 0.05 milligrams. In terms of drugs, 1 IU of standard preparation insulin represents 45.5 micrograms. 1 IU of standard preparation penicillin equals 0.6 micrograms.
Who was Omar Khayyam?
Omar Khayyam, 1048 to 1131. Who was actually known as Al-Khayyami, was a Persian mathematician, poet, and astronomer. He wrote the treatise on demonstration of problems of algebra, a book that contains a complete classification of cubic equations with geometric solutions, all of which are found by means of intersecting conic sections. He solved the general cubic equation hundreds of years before Niccolò Tartaglia in the 16th century. But his work only had positive roots. Because it was completely geometrical, see elsewhere in this chapter for more about Tartaglia. He also calculated the length of the year to be 365.24219858156 days, a remarkably accurate result for his time, and proved that algebra was definitely related to geometry.
What is computational biology?
Computational biology refers to biological studies that include computation, mainly with computers. Many biologists study computational biology to develop algorithms and software to manipulate and analyze biological data. They also use computers to develop and apply certain mathematical methods to analyze and simulate molecular biological processes. Another good reason for this marriage of biology and computers is obvious in today's world: the genome, human and otherwise. to take on the giant task of mapping genomes, the entire collection of genes in a species. Scientists have turned to the computer, using it for such studies as genomic sequencing, computational genome analysis, and protein structure analysis. Computational power is needed for a plethora of other tasks, too. For example, it is being used to develop methods to predict the structure and function of newly discovered proteins and structural RNA sequences in humans and other organisms, to group protein sequences into families of related sequences, and to generate phylogenetic trees or lineage trees, such as the human relationship to apes, to examine evolutionary connections.
What are calories?
To most people, calories are usually associated with a very large piece of chocolate cake. But in that case, they are called nutritionists' calories, or the unit of energy producing potential, equal to the amount of heat that is contained in food and released upon oxidation by the body. The body needs the calories in the foods we eat to use as energy. This is why nutrition and weight control texts often contain such entries as a 140-pound person walking for 1 hour at a moderate pace burns off 222 calories. In chemistry, a calorie also refers to a unit of energy. But in terms of chemical experiments, a calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius from a standard initial temperature at a pressure of 1 atmosphere, sea level. The unit measurement for energy is a joule, in which 1 calorie equals 4.184 joules, 1 joule is translated most often in metric, as the energy needed to lift 2000 grams a distance of 10 centimeters.
What is mathematical medicine?
Mathematical medicine uses math to understand certain medical problems. For example, some medical researchers are using noises and sounds from a patient's lungs as a diagnostic tool. Based on the quality of the sound measured by ear or mathematical analysis of a frequency spectrum, it may prove to be a non-invasive way of detecting lung disease. Other examples are the mathematical modeling of how drugs are delivered through the body to target diseases and the mathematical modeling of the progression of age-related macular degeneration. Overall, mathematical modeling and simulation techniques are the most important part of mathematical medicine, and will likely be used in the future to help solve problems with the human body.
Why did the Egyptians choose the pyramid form?
Historians know that the Egyptian sun god, with its rays reaching for the sun, was represented by pyramid-shaped stones, or benbens. And because the Egyptians worshipped the sun as their chief god, The pyramids are thought to be huge renditions of the Ben-Bens. After a pharaoh died, the pyramids would be symbolic of the pharaoh ascending the sun's rays to join his sun god. Some historians also believe that the pyramids may have had some, still hidden, numerical significance. In particular, some believe the ratio of the pyramid's perimeter to its height times 2, or p/2xh, gives a close approximation to the value of pi. Another claim is that the slopes of the pyramid sides were also expressions of pi.
How is an aneroid barometer read?
Well, a falling hand on a barometer indicates a low pressure system is on the way with poor weather. Usually a storm with snow or rain. A steady barometer means there will be no changes with the ongoing pressure system. And a rising barometer means high pressure and fair weather. An even higher reading, around 31, means an extremely dry atmosphere. The timing of the barometric change is also telling. A change of a degree either way in a few hours means that the weather will change quickly. A slow change of 0.3 or so a day indicates weather arriving in 12 to 24 hours. A quick rise in the barometer also often indicates high winds and unsettled weather. All barometers work because of our weather systems. Changes in air pressure are caused by differences in air temperature. And this, in turn, creates the wind and weather patterns that carry the high and low pressure systems around the Earth's lower atmosphere.
Why is Greenwich, England, called the prime meridian?
The reason for Greenwich, England, being the prime meridian is historical. An imaginary line passes through the old Royal Astronomical Observatory, which was chosen by astronomers of the day as zero longitude. The observatory is now a public museum located at the eastern edge of London. It is a great spot for tourists who can find there a long strip of brass that stretches across the yard marking the prime meridian. Here it is possible to straddle the line with 1 foot in the Earth's eastern hemisphere and the other in the western hemisphere.
Who was Pierre de Fermat?
French mathematician Pierre de Fermat, 1601 to 1665, made many contributions to early methods leading to differential calculus. He was also considered by some to be the founder of modern number theory. See Math Basics, and did much to establish coordinate geometry, eventually leading to Cartesian coordinates. He supposedly proved a theorem eventually called Fermat's last theorem. It states that the equation xn plus yn equals zn has no non-zero integer solutions for x, y, and z when n is greater than 2. But there is no proof of Fermat's proof. making most mathematicians skeptical about his supposed discovery.